Okay. So let's solve lead code 287, maximum number of k divisible components. There is an undirected tree with n nodes labeled from 0 to n minus 1. You are given the integer n and a 2D integer array edges of length n minus 1, where edge I is equal to ai comma bi indicate that there is an edge between ai and bi in the tree. You are also given a zero index integer array values of length n, where value I is the value associated with ith node and integer k. A valid split of the tree is obtained by removing any set of edges, possibly empty from the tree, such that resulting components all have values that are divisible by k. Okay, so where the value of a concatenated, okay, so where the value of a connected component is sum of values of its nodes, returning the maximum number of components in valid split. Okay, so we have a tree 1 2 3 4 0, and we got values. So what we do is 1 2 3 4 edges there. According to this, we remove the edge connecting node 1 to node 2. The resulting split is valid because the value of the component containing node 1 and node 3 is value 1 plus value 3 is equal to 12. Okay, so value 1 plus value 3 is 12. Okay, good. The value of the component containing node 0, 2, and 4 is 6. Okay, so what we get output is 2. So the number of components we were able to break the tree into is our output, and we have to break the tree into such components such that each component sum turns out to be divisible by k. Okay, so let's go to our whiteboard and okay, switch to text. Okay, what our tree looks like: 1 2 3 4 0. Okay, so here's our tree: 1 2 3 and 4 and 0. Okay, so this looks like this. So since it is a tree and I need to break it in as many as components as possible, so if I start from the top, I don't actually think starting from the top is good in these kind of questions, because although this seems perfect, we can start from one, then we can add two, but we will only be checking a single side at once. That would be quite sucking to precise of. So instead of that, I always like to look at these questions from downside. So what I can do is start from the last leaves node, so 4 and 0, and 4 check whether 4 is divisible by 6 or not. Since 4 is not divisible by 6, I will return 4 to its parent, and similarly I will check for 0 whether it's divisible by 6 or not, and since it is not divisible by 6, I will then send 0 also. So here 0, here I return 4, and in the similar fashion I can have my current root. Okay, and this can be my left sum, L sum, and plus R sum plus root. So now 4 plus 0 plus 2, which is divisible by 6 because 6 is 6 divisible by 6, which turns out to be true. But the thing is that, okay, so very first thing that I was missing was it's an edges. So I would need to run a DFS instead of a tree. So if it was a tree, I would have done this LSUM and RSUM. But since it's a graph kind of a tree, so just every tree is a graph. So that's a different story. So what I will do is start a DFS from our root node, go to the every node and check every node whether it's divisible by the particular k or not. If it is not divisible by the k, I will send the value back to the parent node. In similar fashion, check for the other childs of the parent node, and for every node, I will check out this value, and then if this particular sum is divisible by k, since this 246 is divisible by k, I will be breaking it off. So now since when I break it off, then what I have to return is a thing. So instead of that, what I would like to do is I would do one thing, that is return 0. So whenever sum is divisible by k, then I won't return anything back to the parent node. I will just return a 0. So for this one, this DFS call returns a 0, and this DFS call will return 3, and 1 plus 3 will be 4. So what's the value of k here? The have value of k is 4. How can we 1 plus? Okay, so the values is 1 plus 3. Okay, the values, I was just confusing. Okay, so values 1 plus 3 is 8. So the values array is given to us. So that's not a matter. So what our basic idea would be something like this. So let's make the tree once again, like it's node 1, 2, 3, 4, 0. So 1, 2, 3, 4, and 0. Okay, so I will start a DFS call, and this DFS call will reach my last leaf nodes, which are in a tree. So these will be leaves node, and these leaves node will check whether they are divisible by k or not. Since they are not divisible by k, they will return their value to their parent node. Then we will add the value of parent node with the current value that we have got from the child nodes. Add it, check whether it is divisible by k or not. If it is divisible by k, break the particular component, return 0 to the previous parent node, and in similar fashion continue this way. So this particular problem is said to be hard. I would say it easy if you solve some similar problems, or even have make some similar questions which were just about adding a sum. Okay, so what should be our code like? So okay, let's create a count which can be 0 initially. I think this count would be 0. Now what I want is a DFS. Okay, so int DFS, we are returning a sum. What we are having is particularly a node. Then we have vector and vector int edges for our edges. Great, edges, and then we have visited vector, definitely, because are having nodes, we need to maintain a visited vector in DFS. Well, it can be done without visited. You can use a parent, but we can just keep it there. Val vector that we will be getting. Any more thing? Yes, key, definitely key. Okay. After this, what we want is every time I come, I mark my visited as 1 because DFS, and then I have int sum which is initially 0, and for auto x, that will be in my in edges that I have. Okay, so I've named it edges. Okay, edges bracket I. Okay, so for this I have edges, and what I would like to do is not state my particular x, then some place would be my DFS, and where from I will start my DFS is this particular x node. Yes, this particular x node will be starting my DFS, and I have my edges. Okay, edges goes here. We have adjacent, and then what we have visited, and then we have val, and then we have key. Okay, good. Now okay, so here edges and this edges will just be same, so just rename it. Let's just name it graph. Much better. Graph, and then what we'd like to do is just sum plus this particular var that we have, this node I. If sum modulus k is equal to 0, then just do one thing, increase the count because you have encountered a component here, return 0 to the parent because there's nothing to return back here, and just return the sum. Okay, now let's move down to our main code. Now let's create a vector int adjacent, or we can call it graph. It's like made it. It will have n edges, so let's put n there. Vector int visited, but n comma 0. Good. Now for auto. We have this. Okay, graph. I have here I bracket 0 dot push back I bracket 1, and in similar way create a graph that has I bracket 1 dot push back I bracket 0. Okay, good. Now just do a DFS, simple DFS from the node 0 to adjacent matrix called graph listed values and k, and return the count. Okay, that's good. Return the count. That's all I want. Okay, let's try to run this, see what happens. Okay, pending. Okay, edges and there's graph. Okay, good. Good lord, where there is here. Okay, I have created graph, so graph will be there. Let's see. Okay, another compilation error. What it is? Again, in edges error. You have to get graph here. Da, 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 da. Again, in compilation error. What happened? Okay, why have adjacency matrix when we already have a graph? Okay, so it's running fine. Let's try to submit it. Okay, then we get a runtime error. Okay, so where is this runtime error? Okay, so it's causing problem because of int. So instead of int, just let get it done with long. So instead of int, just use long here and long here. Let's try to run it and see. Hey, it's running. Okay, so that's all for the problem. This problem is quite, I would say, easy level problem, not even medium level problem, because if you solve some tricky questions, then it will be pretty easy for this problem. Okay, that's all for this problem.